Hey guys, and welcome back to another video on the channel. In today's video we're going to be finding the divergence and curl of another given vector field. So we just did one previously with this corresponding example. I don't know which video I'm going to post before the other, but you'll see them eventually. So this is the given vector field in this example. So f, and it's a 3D one, so x, y, and z. Or we'll use the three coordinates pretty much. The output will be something else. X squared y of I plus negative x on y, j plus x, y, and z, k. Okay? Righto, so to find the divergence, you pretty much dot this vector with the vector d. So vector d is the partial derivative of x for your x component, the partial derivative of y with your y component, and the partial derivative of z with your z component. Okay? So when you're dotting this with this vector here, it's literally just going to be this times by that, that times by that, and that times by that. When you do the curl, it will be the cross product, okay? So this is quite an important vector you need to know with vector calculus, okay? So for divergence, it's going to be d dotted with f, okay? So the way you set this up is just x's times x's, and then you add them with the y's times y's, and then you add them with the z's times z's, okay? So it's just going to be d of x of this thing here, so x squared y plus d of y times by this thing here, negative x on y plus d of z on x, y, and z. Okay? Now, when looking at this thing here, you've got to differentiate with respect to the corresponding variable, because the other variables are now treated as constants because of the partial derivative. Okay, so when I differentiate this first bit here, all I'm looking at is the x squared here. Okay, because the y is a constant, and we're only differentiating with respect to x. Okay, so the first bit here, so d dot with f is going to be 2x, and then you leave the y because it's a constant, plus. Now differentiating this guy here, what we have is a 1 over y. Now, if you differentiate that, you've got to pretty much change how it looks. This is the same as y to the negative 1, and then you can use the power rule. So if I were to differentiate this, I could then move that negative 1 down the front, so I get negative y, and then subtract the power by 1, so minus 2. So when I'm differentiating this guy up here, it's going to be negative x times by negative y to the minus 2. So if you want, you could rearrange that, because a negative times a negative is positive. So then you get x on y squared. Okay? Plus, and then you differentiate the next bit. So just looking at the z. So if you differentiate z, you just get 1. So you're just going to have x, y at the end. And that's the divergence of your corresponding field. You can simplify it if you want, but there's really no need for it, because it would just take a lot of effort pretty much. The one thing you could probably do is just these guys here, because they are like terms considering, so I could just change this to a 3 at the front. And that's about it, really. You couldn't really simplify that other than that and get rid of that plus. Okay. Now to find the curl, it's going to be d crossed with f. Okay. So what you do is you set up a 3 by 3 matrix. So you have I, j, and k on the top for your corresponding components. Then you write the first vector. So this guy here in this top row here. So this would be dx, dy, and dz here, okay? And it's going to be crossed with the vector f, so it's just going to be this component on here, so it'll be x squared y, negative x on y, and then x, y, z, okay? So now, when you do evaluate a 3 by 3 matrix towards determinant, you have to break it up into 2 by 2s, because we can only find the determinant of a 2 by 2. So when you use a matrix higher than that, you have to break it down into a smaller matrix, okay? So remember, it's got to have the pattern plus, minus, plus. So your first matrix here is going to be this one here. So it will be equal, so this will be for your x component, dy, dz, negative x on y, x, y, and z, and this is multiplied by whatever's in this corner here, so this will be I. Now I'm going to actually just start writing it down here, because I don't think there's going to be enough room for it, so I'll just move this guy down here. So that'll be for your x component, because remember, the cross product, you want a vector as a component. With the divergence, you usually get a number, but because it's for a vector field, you've got an expression, so you need a set of coordinates, and then you can find the divergence at that point here. We are finding a vector, okay? Right, so then the next bit will be this 2 by 2 here. And this one has to have a minus in front because it has to follow the pattern plus, minus, plus. So it will be minus, square bracket, so del x, del z, x squared y, and then x, y, z. And this is for your y component, so j. Okay. And then the final matrix that we're trying to find is this one here. So it will be plus, because it's got to go plus, minus, plus, and plus, minus, plus. And then this will be del x, del y, and this will be x squared y on negative x on y, and this will have the k, okay? Righto, so to find the determinant of a 2 by 2, so we have a, b, c, d. To find the determinant of this, it's just going to be this times by this, so a times d, subtract this times by this, so minus b times c, okay? So you've got to do that for each of the 2 by 2s we can see above, okay? So this guy here, let's just do them individually because if you do it all at once, you'll probably get confused, and it's probably not the best way to do it. So this one here, it will be this times by this, so del of y, x, y, z, subtract this times by this, so del z on negative x on y. And remember, whatever this result is, it will be a component of a vector, okay? So when looking at the first bit here, if you're differentiating with respect to y, the only thing you're getting rid of is this guy here because of a power rule. So the first bit here will be xz. Differentiating this with respect to z, it's going to be 0 because there's no z's involved. So your corresponding component will just be xzi, okay? If you have any questions about that, leave something in the comments and I'll try my best to answer it. But let's move on to the next component, okay? So this guy here, same thing, except the negative is just at the front, okay? So before you do anything, just go equals and chuck a big negative in a square bracket so you don't forget that later on, okay? So this negative is just pretty much this guy here, okay? Then it's going to be this times by this. So it'll be del x, x, y, z. Subtract this times by this. So it'll be del z of x squared y. And then we can work this out. So differentiating this, you can see that x is going to disappear, so you're going to get negative of yz. Differentiating this, you can see there's no z, so it's going to be a fat minus 0. So you get negative yz as your j component, okay? And then we work out the final one here. So we'll go copy this, copy. So this one here, it's going to be this times by this. So del of x, negative x, y, subtract this times by this. So del y of x squared on y. And this is your k component, okay? Or z component. The k represents the z anyway, okay? Differentiating this, you can see that x is the only one we're differentiating, so it's just going to be negative 1 on y for that first bit. And this second bit, you can see there's only one y involved, so it's just going to be x squared as your result, so it'll be negative x squared. So this is your k component, okay? So now that we've got all the components, so we've got this component, this component, and this component, the cross product of del crossed with f, so the curl is going to be x, z, I minus y, z, j plus negative 1 on y minus x squared times by k. Right. And that's how you find the divergence and curl of this vector field. We did this example in the previous video. I don't know which one will get uploaded first, but you'll see which order is eventually. It's the same stuff pretty much. But yeah, if you have any questions about any of this, leave something in the comments and I'll try my best to help. I'll probably do a 2D example and probably sub in a point so we can work out a couple things. But yeah, I'll see you in the next one.